Hey everyone, Katrina here, and today we're going to talk about the difference between even and odd degree polynomials versus even and odd functions. Be sure to subscribe for more videos like these. Okay, so this has been a common question that many people have asked me. They've asked me, okay, is even degree polynomials the same as even functions? And the answer is no. So we have to make this distinction here between when we have something that's called an even or odd degree versus an even or odd function. So when we talk about even and odd functions, there's a lot more restrictions placed on this definition than the definition of simply an even or odd degree polynomial. So we're going to first talk about even and odd degree polynomials first talk about even degree polynomials and then even functions, then go into odd degree polynomials and odd functions. So stay tuned for the whole video. Okay, so let's first talk about this concept of even degree polynomials. So when we talk about even degree, we're simply just looking at one element of our polynomial, and that is the degree of the polynomial. So here, say for example, we have some polynomial p of x. It equals to 5x to the power of 6 minus 7x cubed plus 2x minus 9. So if you need some help classifying or understanding what the degree of the polynomials, also be sure to watch my Introduction to Polynomials video, which goes over that information as well. So simply put, the degree of a polynomial equals the largest degree of x. So in this case, if we look at all our x's, so we have x to the 6, x to the 3, and x to the 1. So what is the largest degree of x? Well, we have a 6, a 3, and a 1. So 6 over here is going to be the largest degree of x. So therefore, our degree equals to 6. And now we have to ask ourselves, is our degree an odd number or is our degree an even number? Well, in this case, we can see that 6 is in fact an even number. So therefore, this polynomial is an even degree polynomial. All we had to do was simply look at what is the largest power of x, what is the degree, and then determine whether this is an even number or an odd number. We do not care what the rest of our polynomial looks like. This will come up when we discuss even functions, but for even degree polynomials, the only thing we care about today is the degree of it. What is the largest power of x? Okay, so that is an even degree polynomial. Now let's take a moment and look at what are even functions and understand that definition as well. So even functions, like I mentioned, have a stricter definition. Algebraically, even functions have to have this form. You have to have f of x equals to f of negative x. So essentially what's going on here, if you think about transformations, is that this negative represents a reflection over the y-axis. So that can be thought of as your horizontal reflection. So that's how you would think about it graphically, and then this is how you would think about it algebraically. So if you were to take an example over here, we might have, let's say, f of x equals to x to the power of 4 minus x cubed plus 6. So in this case, we can right away see that the largest power of x equals to 4, and 4 is an even number. Therefore, this is an even degree polynomial. But now let's check, is this an even function or not? So let's go ahead and put a negative in front of our x and do the test. So now we have negative x all to the power of 4 minus negative x all to the power of 3 plus 6. So if we are to evaluate this, we get x to the power of 4 because we have the even exponent. Then we're going to get negative x to the power of 3. And this negative stays here because we have an odd exponent, and then when you have two negatives, it becomes a positive. So therefore, we have plus x to the power 3 plus 6. Now let's compare our first function to our second one. So in this case, we see that f of x does not equal to f of negative x. So that means that, therefore, this is not an even function. But we did see that we saw earlier, we already mentioned, that this is an even degree polynomial. Okay, so this is a case where the function is not an even function because that has more strict, has a stricter definition. However, we do see that it is still an even degree polynomial. So let's go ahead and do a similar analysis, but for odd degree polynomials as well as odd functions. So odd degree polynomial is going to be similar to the even degree polynomial, except for in this case, we have to have that the largest degree of x has to be an odd number. So here, what if we have f of x equals to 9x to the power of 11 plus 4x4 minus, let's say, 3x squared plus 72. So just like we have to write our polynomials, we have to write them in decreasing order of the degree. So we start with 11, 4, 2, and so on in decreasing order. So in this case, we have to identify what is the degree of this polynomial. And we already mentioned that the degree is the largest power of x. So we can see that the largest power of x in this case equals to 11. And is 11 an odd or an even number? Well, 11 is an odd number. So then, therefore, we have an odd degree polynomial. Now let's look at the stricter definition and take a peek at what an odd function looks like. So an odd function has the following algebraic definition. We have to have f of x equal to negative f of negative x. And now if we want to look at the graphical or the transformation side, let's take a moment to see what we have here. Well, just like before, we have the negative in front of the x. So this means that we have a reflection over the y-axis, so our horizontal reflection, but then we also have a negative out front. And this represents a vertical reflection, which would be a reflection over the x-axis. So since we have two reflections here, over y and over x, together what this means is that we have a rotation of 180 degrees. So that means if you were to rotate your function 180 degrees, it will end in the same position that it started. So it will appear unchanged. So now let's go ahead and do an example to determine if we have an odd function. So here let's consider the polynomial f of x equals to x to the power of 5 plus x squared minus 1. And let's do this the algebraic way. So we're going to do it in two steps. So we're going to start with the negative within the x as step number 1, and then we're going to apply the negative on the outside as step number 2, just so our example is a little bit clearer for everyone today. So starting with f of negative x, we have to put the negative next to where we see our x in all cases. So we got negative x to the power of 5 plus negative x to the power of 2 minus 1. So our rule here is if you have an odd exponent and you have a negative, then it will remain negative. So that means we have negative x all to the power of 5. Here we have a negative exponent and a negative coefficient and an even exponent, so then it becomes positive. So then we have plus x to the power of 2 minus 1. So that is our f of negative x. So that was our step 1. Now as our step 2, we want to apply a negative to the front as well. So we have negative f of negative x. So we're going to put a negative, we can put this in pink, outside of our entire function. So we've got negative and then negative x to the power of 5 plus x squared minus 1. And now to do this, we have to distribute the negative to each term that we have within our brackets. So as a result, we have negative times negative x to the power of 5. So the two negatives cancel out, and we've got x to the 5. Then we have negative x squared. Then we've got negative 1. So the two negatives again cancel out, and we end up with plus 1. Okay, so that is our negative f of negative x. Let's compare this now to our starting position. So our starting function is up here, and this is what we ended up with. We can see that we have a few mismatched negatives. We've got a plus here and a minus here, and a plus. Oops, a plus right over here. So as a result, we can see that our f of x does not equal to negative f of negative x. So what does this mean? That means therefore it's not an odd function. However, we did see that since the largest power of x is an odd number, then it is indeed an odd degree polynomial. So this video taught you the difference between odd functions and odd degree polynomials, as well as even functions versus even degree polynomials. If you enjoyed this video, please drop a like and comment any questions that you have, and definitely subscribe for more videos. I've got more on polynomials and many other different areas of math coming your way. And with that, I look forward to seeing you next time.